So again, I'm going to start the lectures now. So let me. So we started this topic on Tuesday, rate of change. We talk about average rate of change, instantaneous rate of change. We went through this example. So I'm going to wait for a few again seconds, just going through the slides. If any question. And we said this is the formula. Actually, when we see this formula, that's the beginning of derivative. We are going to derive all the formulas, multiplication, addition, subtraction, division, all the formulas from this formula. So as I said the last time, we may have a question, and the question we said, find the derivative of this function using limiting process. When they say using the limiting process, then you have to use the formula. You have to use this formula here. You don't have to use the actual formula to find the derivative. And we did this example. So for example, they say find the derivative of f at x equal to 4x squared. If I'm going to use the derivative formula, I can just say straight ahead the answer. The answer will be 2 times 4, which is 8, because I multiply the 2 exponent by the coefficient 4, which is 8, and I'll subtract 1 from the exponent. So my answer will be 8x. I'm using the formula. It takes a second, a few seconds, that's it. But if the question say use the limiting process, then you have to use, then you have to use this formula here. You have to use, again, if we start to be on the campus, you may see a question like this in the other quiz or midterm exams or but normally, as I said earlier, if we are going to do mostly online, then the exams will be multiple choice. So you don't need to show, there will be no question that show the limiting process, because multiple choice, you don't need to show your work. But again, if we start the campus or IFRS, then you can see a question like this. Normally in the campus, there's no multiple choice questions. All the questions you have to solve it, or whether exams or quiz or homework, you have to solve. So again, we went through this on Tuesday. So this is the limiting process. We can see the answer is 8x. All we need here is algebra skill. We already know the formula, which is right here. So just plug in the values. It's just a substitution. Anywhere I see x, I'm going to replace it with 4x squared. And that's what we are doing here. This is x plus h. So anywhere I see x, it will be s plus h now. That's why we have 4s plus h. Then 4s squared. Then we just solve the equation. So this is where we reached last time, and we were able to finish this. And this is where we are going to start today. And here we're starting with the terminologies, or I would say the notations for derivative. So in our textbook, we may say f prime at x. This is the symbol for derivative. Or we may say dy dx. Also, it's a derivative. Or we may say y prime, or d ds f at x, or dxy. This means we are finding the derivative related to the variable x. Or dx f at x. Y is the same as f at x. But in our textbook, most of the time we use the symbol f prime at x, the first symbol here. Sometimes we may say dy dx. And also this is a business calculus, so we will see that most of the applications we are going to solve, we are going to use business application. So for example, they will say a question will be given and the revenue function is given. Or it can be the total cost function, or it can be the expensive function, whatever function it is. But the term here, marginal, means we are looking for the derivative of that function. So marginal revenue means we are looking for the derivative. Again, as we said earlier, calculus normally deal with the rate of change of something, but the rate of change is not constant throughout. So that's the whole concept of calculus. So here for linear functions, of course, it will be constant throughout, rate of change. But non-linear function, the rate of change from one interval to another interval may not be constant, because we may say curves around. So we say here for linear function, we define the marginal revenue for the product as the rate of change of total revenue function for the product, which is almost the same concept as finding the slope if it's a linear function. But if the total revenue function for a product is not linear, this is where calculus comes in, derivative comes in. We have to define the marginal revenue for the product as instantaneous rate of change, or derivative of the revenue functions. And we saw it here. Let me go back 1 second. We saw the graph here, which explained to us. Yeah, so this is the whole concept we are trying to do. If it's linear function, then it's constant. It's like finding just take 2 points on the line, whatever interval, because any interval on the straight line, the slope is the same, or the average rate of change will be the same. But again, if it's non-linear, well, we have changes between. So average rate of change, then we can find our whole concept start with this instantaneous rate of change. That's the whole concept of derivative. So again, this is the formula again for the limiting process. We can see that the only thing we are doing here, we are changing the symbols. Since this is a marginal revenue, instead of saying F, we say R. And the textbook use prime a lot. So R prime at X means the derivative of R. Again, prime means derivative of the function. So it will be, again, this is the limiting process, to be the limit H approaches 0, R at S plus H minus R at X. Again, provided that the limit exists. So here we have a question here. We can see that this is only R at X. So this is the function. The function, revenue function, is given to be 100x minus x squared. X must be greater than or equal to 0. And this function, they say, suppose that an oil company's revenue, so this function is about a company's revenue in thousands of dollars, is given by this equation. S to be the number of thousands of barrels of oil sold each day. So S can never be negative. It have to be positive. How many products I sell? If I don't sell nothing, then it's 0. If I sell something, it can be 1, 2, 3 up. It can never be negative. So that's the condition they give us here. Now, our question now said we should find the function that gives the marginal revenue at a value of X. Now, we don't know the number of barrels of oil that we sold, but we want to find the marginal revenue. So this means we have to find the derivative of this function. Now, using the formula, the answer here will be 100 minus 2x. That's it. So when you know the formula in your head, you solve it in a few seconds. 100 minus 2x. But again, here we are going to use the limiting process. Now, when I get 100 minus 2x, B said find the marginal revenue when X is 20,000. That's the number of barrels of oil sold is 20,000. So this means I'm going to substitute S with 20,000, then I'll find the revenue the oil company will generate when they sell 20,000 barrels. But again, here we are not using the formula yet. So we have to follow the long process. This is the limiting process. So we are going to substitute. Our function is 100x minus s squared. So anywhere I see the first section, anywhere I see X, I'm going to include the H on it. And the second one, R at X, the function also is R at X. So I just substitute the whole function here for R at X. But when you look, the function name, the function is R at X. So I'll substitute everything here. But the first one is S plus H. So it will be 100 times S plus H, then S plus H all square, because I have to include plus H in the X. So this is what we get. We have our 100. Instead of 100x, we say S plus H minus, instead of saying S squared, we have plus H. So it's S plus H squared minus R at X, which is the whole function again. So now we need to solve this. We're going to open the parentheses. Again, here we're going to use our algebra or pre-calculus skill. So when we open the parentheses, this is what we get. This is perfect square, so this will give us S squared plus 2SH plus H squared. And that's what we have here. To open this parenthesis means the signs will change. 100 will be negative, S squared will be positive, and that's what we have here. Next, we're going to open this parenthesis, so all the signs will change again since we have negative outside. And we combine together, and this is what we get. Now, we can see that we have H common. So I'll take H out and I'll cancel with the denominator H. So I'll get 100 minus 2, 100 minus 2S minus H. We have one more H left because this is H squared. So since the limit H approaches 0, our answer will be 100 minus 2X. Again, as I said earlier, if I know the formula, I can just set the answer here. 100x means it's 100. The reason why it's 100 because s is exponent 1. Always you subtract 1 from the exponent. That's the power rule. So I will get 1 minus 1. So s to the power 0 will be 1. So I'll get 100. Here 2 minus 1 will give me 1. But I have exponent 2 and I'll multiply with the coefficient 1. So I'll get 2x. So the answer will be 100 minus 2x. And when we follow the limiting process, we should get the same answer. So 100 minus 2x. So the marginal revenue will be 100 minus 2x. Now B said when we sell 20,000 product, 20,000, but here the formula here is in 1,000 units. So we substitute with 20 and we get 60. So when the company sold 20,000 units of the barrels of oil, they generate a revenue of $60,000. $60,000. Now, sometimes we may have a question and we want to find the rate of change or what would be approximately the difference if we sell 20,000 or 21,000. Now here we say because the marginal revenue is used to approximate the revenue from sales of additional unit. We can use the marginal revenue to approximate additional unit. We can interpret derivative of R at 20 equal to 60 to mean that the expected revenue from the sale of next thousands after this will be also 60,000. So R21, again here I'm going to the original function. We can see this is R, not R prime, R21 minus R20. If I use my original function and I substitute 21 and 20, you will see that your answer will be close to 60,000. Here we get 59,000. So that's the key here. The marginal revenue is used to approximate the revenue from the sale of any additional product or additional unit. So if 20,000 give me this, to move from 2, 1 to 2, 0, 1, or even from 2, 2 to 2, 3, it will give you the same answer. So now we go to the tangent to a curve. So this will give us the concept of, again, moving to derivatives. So here in geometry, we have a circle. So a tangent to a circle is defined as a line that has one point in common with the circle. So we can use the concept of tangent line to derive the slope of nonlinear function. So if I have a circle, the tangent to the circle will be, if I draw a line, the single point that touches the circle, in this case, the A, will be our, again, tangent. So let's see, here we have so many of them, because, again, the concept here means the slope will be changing. I have the same point A, but the straight line depends on the steepness. So we can see different directions, but they're all crossing the same A, the point A. And this is the concept of what we call the secant line or secant lines. And the whole concept came from, again, the derivative. So here we have some 2 points, some interval we can see here now. This is almost like the previous diagram we have to derive this formula. So previously we have only 1 point. Now if the line crosses 2 points on the circle or on the function, the interval between the two from A to B, we can find the slope or rate of change. I will use the term rate of change. So it's the same formula we have now. Here we say, okay, we are starting from X to S plus H. So if I take the 2 points and the difference of X and S plus H is H, it's like using the slope formula. My first point is S1, F at S1. Second point is S1 plus H and F at S1 plus H for the function. That will be the Y. So the difference of the vertical divided by difference of the horizontal. Horizontal will give me S plus H minus X. So the S's will cancel each other. That's why we have H here. So this is a repetition of the same formula, the average rate of change, instantaneous rate of change. And this is what we said before. Slope of the tangent is what brings the concept of derivative. So we say the slope of the tangent to the graph y equal to f at s at a point of 2 is what we have here. So m is the slope, the difference of the vertical y axis divided by the difference of the horizontal. The horizontal is h again, because as we said, if I have x and I have s plus h, the difference of s plus h and s will give me h. So that's the line here, h. The difference of the vertical will give me f at s1 plus h minus f at s1. So the slope will be difference of y divided by difference of x. So we can see that again, the whole concept of derivative is derived from a slope. If it's a linear, as we said earlier, actually the beginning lectures, if it's linear, we take points at anywhere. But this is non-linear. So rate of change will change based on the curve. If next time I take 2 points other than where we are now, I take different 2 points and I draw a tangent line, the slope there value will be different from this. So now we have example here. They say given a function f at s equal to 3s squared plus 2s plus 11, we should find the derivative of the function. f at x at any point x and f at x. Now, if I'm using the formula, my answer will be 6x plus 2. That's it. Derivative of a constant value is 0. But here we are going to use the limiting process. Now, when I get the answer finished, 3x plus 2, I can find the slope of the tangent y and 16. So y is the tangent will be the point. Let's say the point A. Point A have a x value and y value is a point. And that's the point they give us here. So I'm going to substitute this point inside the derivative of the function. Then I'll get the slope. Next, they say we should find the equation of the tangent line to this. And again, if you have, this is like pre-calculus. If I have an equation and I have the function, let's say if we have two lines, they give me one line function and the slope, I can find, and if the line is parallel perpendicular, I can find the second line equation. And that's the idea here. But again, a little bit different way of solving it. We'll see it right now. So let's start with the A first. A is straightforward. Again, we are using limiting process, so you have to use the formula. So this means anywhere I see the first section, anywhere I see S, I will replace it with S plus H. So I'll get S plus H squared times 2S plus H, then 11. Then f at x, I'll just copy all the function here to f at x. Then we just solve it. So this is what we get. The function f at x is the same thing on my right side. The left side, the only difference is that anywhere I see s, I also have to include the h. So s plus h squared, s plus h, 11. Now open the parentheses. First of all, we find the perfect square here. We multiply by 3. We multiply 2 by everything here. We open these parentheses, changing the signs. And this is what we get. Next, we multiply by 3. Then we combine the like terms. So for example, we're going to have 3s squared here. 3s squared, we have minus 3s squared. So they will cancel. Positive 3s squared minus 3s squared. Then let's see if we can cancel the 2sh. H squared, we cannot cancel it. We're going to cancel 2x and minus 2x. We're also going to cancel plus 11 and minus 11. So we combine everything. This is what we get. We get 6sh. We couldn't cancel the h squared, so we'll have it. It's 3 times the h squared, so it's 3h squared. We couldn't cancel the sh, so we have it here. It's 3 times 2, so it's 6. And we have this 2h we didn't cancel, so that's here. Now we can see that h is common again. So we're going to cancel h's out. It will left with only 3h in, so we get this 6x plus 3h plus 2. H is approaching 0, so 3h will go away. So our final answer will be 6s plus 2, which is what we said earlier. Again, if you are using the formula, I'll just look at it. I say, okay, 2 times 3, 6x plus, again, 2. This is 0. So we get the same answer. Now, B said we should find the slope, and they gave us the point, 1 and 16. That's the tangent to the curve at the point 1. And this is like the point A in our circle of the curve, nonlinear function. So as we said earlier, anywhere you see x, put 1. Anywhere you see y, put a 16. And that's what we did here. So we can see how we can find the slope of a tangent line touching a nonlinear function. First, you find the derivative of the nonlinear function, as which we just did now. Then that point, it should have it's a 2 dimension, so it should have s and y value. Then you substitute the s and y value inside. But in this case, I have only 6s plus 2. I don't have no y value. So all I need to do is to substitute only the x. So 6 times 1 plus 2, and that give me 8.
Professor, how do you find the derivative?
Yeah, that's what we did right now. This is the process of finding the derivative.
Oh, okay.
Yeah, so this is the function 3x squared plus 2x plus 11. So to find the derivative, we are using the limiting process. Now, this is the formula to find the derivative of any function. The problem, we are not going to use this because if it's a multiplication or division, we are going to spend the whole day to find the derivative of it. So this will move us to the next topic, which we're going to learn about the derivative formulas. Now you can see we use the formula. Anywhere I see s square, I'm going to replace it with s plus h square. So I get s plus h square times 2s plus h. This is f at x. The whole function name is f at x. So I'm going to just put everything here. And then we follow the process. But as I said, if I'm going to use the formula, 3 times 2, 6. 2 minus 1, 1. So here I'll get 6s. 1 minus 1 is 0. Always the exponent you are going to subtract 1. That's the power rule. Then 1 times 2 is 2. So my answer will be 6s plus 2. So if you know the formula, the derivative formula, calculus is about formulas. So if you know the formula, you just get the answer in less than 2 seconds. But if you don't know the formula, you have to use the limit process, and that's what we are doing now. We haven't started, so I just substitute all the value, which is a long process. So the first part of the formula said f at s plus h. So anyway I see x in the function, I'm going to replace it with s plus h. And it's squared because it's 3s squared. 3s squared become 3s plus h squared. We just open the parentheses and then solve everything. So later we can see that we get the same thing, s plus 6s plus 2. Now B, when you go back to the question, B said find the slope. Now we are not looking for the slope of the, well, let's see if we can get, yeah. I'm not looking for the slope of the line of the function. I'm looking for the slope of the tangent line, which is the straight line that touches the 2 points here. I'm not looking for the nonlinear. I'm looking for the, so the question said the slope of the tangent to the curve at this point. So this will take us, which means the first thing you do, find the derivative of the function, which we did at A. Then I'm going to substitute x and y. Again, since the function, we don't have no y, we just substitute the x value. If there's no any variable, then the answer is, sometimes we may find the derivative of a function, and our answer will be the value, especially if the exponent is, the highest degree of the exponent is 1. You see that the expression you get, there's no any variable. So that means that will be your slope. But here we have the variable x here, 6s plus 2, which is the derivative of the function. So we substitute with 1, and this will give us our slope. Now, C said we should find the equation of the tangent line. Uses the given point. We are using the 1 and 16. So if I'm using the 1 and 16, it means I'm going to use the slope given here. Let's go. The same thing they said in the original question. The equation of the line of this at 1 and 16. I'm using this. Now, if the question say, for example, at a different point of, let's say 4 and 20, then I have to go back to the derivative function and substitute 4 for x. Then I'll get a new slope value. You will get, sometimes we may see a question like that. Find the equation of the line, because this line tangent to the function, it can be any point. We can get it from in any direction we want, any point that touches the graph. So since it's the same point, then we have the same slope. So we solve that problem, finish. So now we are going to use our pre-calculus techniques. Oh, sorry. We are going to use our pre-calculus techniques. Remember this formula, point slope. What is it called? The point, yeah. Point slope formula, like y equal to y1 equal to y, I say y minus y1 equal to m times s minus s1 in pre-calculus. It's okay, sorry, it's written right here, y minus y1, and again, we just substitute our points. Remember, the point is 116. So which means s1 is 1, y1 is 16. Substitute it, then we get a new function. Remember, this function is a straight line because the tangent line is always a straight line that will touch the non-linear line. So that point is what is we are looking at the equation. This is the point. So again, this is the same concept as pre-calculus, finding the equation of a straight line. This is a straight line formula. It's a straight line. Tangent lines are straight, touches the non-linear. So I'll wait for a few seconds if any question. What we just did, we're going to do that these are most of the problems we are going to solve in our next section. But the next section, again, we will start to use formulas instead of using the limiting process. But I'm going to wait for a few seconds if any question first before we continue.
So the answer is y equals 8x plus 8, right?
Yeah, that's correct. So this will be our new line equation of the straight line. Remember, a straight line, the highest exponent, the exponent degree for the x is always 1. If it's 2, it becomes parabola. If it's 3, kind of like polynomial function, the stiffness, the shape changes a little. So we are using the same pre-calculus or college algebra. If I have a linear function, I know the slope of that function, and we say the two lines are parallel or whatever they are. Here it means this. Let's go back to the function. Yeah, sorry. This is what it means. We can see that we are using the same point, but now we are finding, let's say the first tangent line was number 1 here. Now we are looking for the second line, but the second line go through the same point, and we have one function. So this is the nonlinear function. We have to find the derivative of this circle or this nonlinear function. Then the target line, the point, we are going to use that point there to find the equation of all the target line. Now, if the point changes, then we find the derivative of the same nonlinear function, then we use the new point of the tangent line. So wait for a few seconds if no question. And this is B. We are looking for the slope. We use the derivative of the function. And here we are looking for a second tangent line at the same given point. So we already know the slope for this given point. So we use the slope, and also we use the point. And we know from college algebra, always the first value of a point will be the horizontal, which is the x. The second is the vertical, which is the y. So you plug it here. So if no question, then let's go through this again. The slides here I'm using is related to the textbook. So everything here again is the textbook slides. So next is the interpretation of the derivative. This will help us to understand application problems. So for example, if a function is given, a velocity of a function can be given, or a function is given and they say we should find the velocity, means it will be the first derivative. If we need to find the acceleration, it will be the second derivative. By here, we are not talking about second derivative yet. We may come to that topic later. So here, for a given function, each of the following means find the derivative, only the first derivative. So if a function is given, and they say we should find the velocity of that function, which means a velocity is something that is moved with a speed. So a velocity of an object moving in a straight line. So the speed. So the function is given and we have to find the velocity of that. Let's say a question is given and they say the moving object function is so. Find the velocity of the object or the moving object. Then we find the first derivative of that function. Same thing if they say we should find the instantaneous rate of change of a function. When the function is given, you just find the first derivative of that function or the derivative of that function. We saw the marginal revenue already. So if a revenue is given, a revenue function is given, and they say we should find the derivative or the marginal revenue, then you find the derivative. Now, if I'm looking for a slope of a tangent line, which we just did right now, the slope of a tangent to a graph of a function, if the graph of the function is given, find the derivative of that function, then we're going to find the slope. So to find the derivative of the function, that will lead us to find the slope. To get the actual slope, we need to get the point. Actually, we did an example of this. So these are some of the questions we may see. So anytime we say find the velocity, instantaneous rate of change, marginal revenue, slope of the function, then you find the derivative of the function. So yeah, we move the next to the differentiability and also continuity. We talk about continuity and discontinuity already. We saw that if you have a function and the function don't have, function is continuity throughout, there's no any breaks or discontinue, that means the limit exists in all the intervals. If there's any discontinuity, the very point that is discontinuity, the limit does not exist. And the same concept here. So here they use a graph to explain to us. So for example, this we can see there's a discontinuity. So there's no way I can find a differentiable or differentiability. It's kind of same as saying derivative. Find the differentiation of a function, the same concept. So if there's a discontinuity, of course, we cannot do it. We cannot differentiate it. Same thing applies to this. Kind of look like absolute function, but here because of the point here, there is a corner point, we cannot. And also this is like an infraction, we cannot. And also when we have a vertical tangent, we cannot also. It can be differentiable at any point, but not at C where the point is. And here we say these cases normally will occur when there's discontinuity or a corner or a vertical tangent line. If a tangent line is vertical, remember a slope, a vertical line slope is undefined, even in our college algebra. Horizontal line slope is 0, but vertical line slope, we don't have no answer for it. So that's why here, same concept. If we have a vertical line for tangent lines vertical, we cannot differentiate. So that's the meaning here. So in the previous figure we saw, we can see that a function may be continuous at s equal to c, even though f at c does not exist. That will be, again, we will go more details on this. This is just to get the concept of the theory. So for example, if a function f is differentiable at s equal to c, then we say that the function is continuous. We saw this example in our previous lecture. When we're doing the limit does not exist when there's a discontinuing that very point. Like if you have a vertical asymptote, it's kind of like a vertical tangent line. The limit does not exist at that point. Okay, so if no question, this will be the end of our section. We're supposed to finish this last week Tuesday, so let's keep going. So this is textbook again 9. Let me make sure everybody. It's our textbook 9.3, chapter 9, section 3. Now we're going to section 4. So now we are going to start to be lazy now. When I say we are going to be lazy, now we have to use the formulas to solve our derivative problems. So instead of going through all the process of limiting process, substitute s plus h, and solving the equation, now we don't need to solve the equation no more. And also in this course, there's no requirement on how we derive the formulas, but again, we may go through, I will explain some of them if it's necessary, how we can derive the formulas using the same limiting process formula, the same formula they use to derive all the derivative formulas. So in here, we will start with the most common rule, which is the powers. So how to find the derivative of the powers of x using the formula. Then we go to the next rule, how to find the constants. And here I will just tell the answer. The derivative of a constant value is always 0. That's it, 0. And also we're going to learn how to find the derivative of a function involving the constant coefficients. If you have a constant coefficient, you leave it. You leave it. So the derivative of 2x will give me 2. The derivative of 2x to the power 3, I will multiply 3 by the coefficient. So the coefficient doesn't affect the formula. Then next we go to how to find the derivative of the sum and differences of functions. So let's start with the power. So we can see the power rule here, f at s equal to s to the power n. If I want to find the derivative of this, the answer will be n times 1. Since x have only 1, the coefficient is 1. So n times 1, then n minus 1 for the exponent. So the answer will be n x n minus 1 to the power n minus 1. And that's what we have here. So if you have a function f at s equal to s to the power n, the derivative of f at x will give me n x to the power n minus 1. This is our first derivative rule, which is the power rule.
Can you explain that one more time?
Yeah, so if you have a function f at x equal to s to the power n, your answer will be n times 1. Since the x here, the coefficient is 1, it will be n times 1. So the new coefficient will be n. N times 1 is n. That's why we have n here. Then you always have to subtract 1 from the exponent. So it will be n minus 1. So it's like you have s to the power n. You put the n exponent, multiply by whatever in front of the x. In this case, it's 1. Then you subtract 1 from the exponent. Now, let's see an example. You will see when we see numbers, it will make sense. But again, this is the formula. Take few seconds to even memorize it. Straightforward, because take the exponent, multiply by the coefficient, subtract 1 from the exponent. That's it. So let's see some examples here. Who can tell us what will be the derivative of u at s before we see the answer? Just by looking at it, s to the power 8. It should take few seconds. So it will be 8s to the power 7. We multiply 8 by s is only, the coefficient of s is only 1. So we multiply 8 by 1, then we subtract 1 from the exponent. So let's see the answer here. If u at s is s to the power 8, then the derivative of u at s will be 8. You see, they bring the 8 down, the exponent will go to the front. Then you subtract 1 from the exponent, so it will give us 8 s to the power 7. I'll wait for a few seconds. Again, look at this section where my cursor is. I have 8 as the exponent, so 8 times 1 is still 8 here. Now, if I have 2s to the power 8, then it will be 8 times 2, which will give me 16. Then I'll subtract 1 from the exponent, so it will give me 16 s to the power 7. Always make sure you remove 1, subtract 1 from the exponent, and you are going to use the exponent to multiply the coefficient of the variable. Here, the coefficient of the variable is 1, so it will be 8. 8 times 1 is 8. Then we subtract 1 from the exponent. So that will be our answer. I'll wait for, especially if this is your, sometimes in the class, I know some students did a little bit calculus. It depends on the high school you went to. Some students go to a science high school. They do a little bit of these materials before they graduate. If you went to maybe business or drama high school or some other tier, maybe this is the first time you are seeing calculus. So try to get you. I'm going to wait for a few seconds here. Make sure no question, then we see another example. And as we said there, the first day, mathematics is practicing. So if this is your first time, just keep practicing, then so that the formula can stay in your head. You get used to it easily. Okay, so seems like no question. I'll go to the second question. Who can tell us what will be the answer for the second question? P equal to, so the P is the function. We can, like saying y, instead of f at s, we say y. So you can see that we have P and Q. The first question say u at s. So s is our variable, so we see the variable. But P by itself, we can say P at Q, since Q is the variable. So the question is okay. P equal to Q to the power 2/3. Now they say we should find the derivative of P. Who can tell us the answer? Then we look at it.
Is it 0?
0? No, first of all, we have 2/3. So we are going to multiply 2/3 by Q. The coefficient is 1. So 2/3 times 1 will give us 2/3. Then the exponent, we are going to subtract 2/3 minus 1. So we're going to get a negative answer. Our answer will be negative 1/3. Remember, if I have a s to the power negative 2, the answer is the same as saying 1 over x squared. So we can bring the variable down and change the exponent to positive. So the same step we do for A. 2/3 times 1 will give me 2/3. 2/3 minus 1 will give me negative 1/3. So let's see the answer. So we can see what we have here. 2/3 come to the front because 2/3 times 1 is 2/3. Then we have 2/3 minus 1. The same thing we do here. 8 minus 1, and 8 is in the front. So we know that 2/3 minus 1 will give us a negative answer. We get, because negative 2/3 is less than 1, so we get negative 1/3. So we get 2/3 Q to the power negative 1/3. Then if we like, we can, since the exponent is negative, we can change it to positive by bringing the Q down. So the final answer can be the Q is now down, so it will be 2 over 3 Q 1/3. It's up to you. You can leave the answer as negative exponent, or you can change it to positive exponent. It's up to you. Hopefully that is college algebra techniques. Now let's look at the C at T. Somebody should help us. Square root of, remember square root of a value, in this case square root of T is the same as saying T to the power half. We know square root is half, the power means half. So who can help us, and then we look at the answer. Come on, guys, let's go. It seems like it's too early in the morning. Everybody knows this by now.
Yeah. So from doing option B on that one,
Yeah, the same step. Yeah,
yeah,
go
it's the
ahead.
same thing. So you switch differential to the power rule. So it will be like half. So n
Correct.
is equal to 1/2.
Yeah, that's correct.
Yeah. So one
So
over
we,
two t to the 1/2 minus 1.
yeah. So the answer, as you said, square root again is the same as raised to the power half. So we
Yeah.
get half times 1 will be half. So our coefficient for t now will be half t. Then remember, we have to subtract 1 from half, the
Yeah.
exponent. So we get negative half, same as what we did here, but only that this time is going to be, instead of 1/3, it will be half, because 1 minus half is negative half.
Yeah.
Then let's see the steps. So this is
So
the derivative
one.
again. We say the square root is the same as t to the power half.
Yeah.
So using the power rule, the half will come to the front. Then we have to subtract 1 from the half. So we get half t half minus 1. Again, as time goes on, you will see more examples. This is the t here can be any value. It can be 2t, it can be 10t. If it's 10t, then I'll say half times 10, which will give me 5. And one thing with mathematics, you'll see that the power rule, we are going to use it in addition, subtraction, multiplication, division. Because if I have any function, let's say I have two functions, they are dividing, but one of the function variable is raised to a power, then I have to apply the power rule there. So that's why we go through the power. Any calculus textbook, the derivative, we always start with the power rule, because we may have a function in addition, subtraction, multiplication, division, and those functions may have a variable with power. Then we have to apply the power rule. Then after that, we apply the whether addition, subtraction, whatever rule. So we're going step by step. After this, I think we go to the constant formula before we finish. We still have we still have time, 15 minutes, 10, 15 minutes. So we should finish soon. We should finish. So if no question, I'll keep going. We get negative, so we can bring it down, or if you like, you can leave it up. We decided to make it positive, so we bring the t down. So our answer will be 1 over t times, or square root of t, or t to the power half. It's up to you. You can use the square root sign, or you can use the exponent value.
Does it matter if we leave it negative or it's okay?
No, that's okay. You can leave the answer this way.
Okay.
But I think most of the time, we know in college algebra, always we like our answer to be positive variables, exponent. The exponent should be positive always. But again, it doesn't matter. It's up to you. Now let's look at the last question. So last question, we have 1 over, it's almost like the first question. Let's go through all the, let's look at the original question. So you can see the first and the last question is the same. The only thing now we add, first of all, if you have a variable in the denominator, remember to bring it to the top. Same thing we just did here. If you look where my cursor is, since I have a q to the power negative 1/3, what I did, I bring q from up down so that it will be positive. Now, if I have q to the power negative 1/3 down, I will bring it up to make it positive. So that's what we are going to do first here. It is better you have positive exponent than you work with it. But in this case, you don't want to find the derivative at the denominator. You want to make the function a whole number if possible. That's better. So that's what I think we did here first. Let's go to D. So D, we can see that 1 over square root of t, we know that the square root of t is t to the power half. So since it's 1 over t to the power half, I bring the t up and I change the power to negative. So in this case now it's straightforward. So now what I will do, I will multiply negative half by the 1 in the front here. So my coefficient will be negative half. Then I will subtract 1 from negative half. So we get negative half minus 1. And negative half minus 1, since it's negative, negative, we are combining. So we get negative 3, 2. So let's see. So we get negative 3, 2 when you combine the two. Get negative half minus 1. Everybody knows fraction by now. The common SCM will be 2. Negative 1. Negative 1 times 2 is negative 2. So negative 1 and negative 2 give me negative 3. So the top will be negative 3. Then we keep the 2. Now, if you like, this is the final answer. You can leave it, or you can bring the t down and change the negative exponent to positive. And I think that's what we did here. We change it. And the final answer will be, again, you can leave the symbol, or you can change we know half, exponent half is a square root. It's t3, so it will be t cubed now. So this will be the solution. Wait for a few seconds. So far we did 4 examples for power rule. Again, we may say this a lot throughout the part of the derivative. This is a calculus. It's kind of equivalent to calculus 1 but here we are measuring business. Business do only one calculus 1. So I would say I would say 75% of the class will be derivatives throughout. Then the 25% of the materials will be antiderivative or integration. So antiderivative means now they give you a function, but the function is derivative. You have to find the opposite way. You want to get the original function. We may do that almost by the end of getting to end of the semester after midterm exam. So the reason I'm saying this is that, again, you will see a lot of these problems as we keep going. So let's move on to the next topic, which is the derivative of a constant. And this will be very quick, as we said. Here they try to prove it for us. So you can see in the proof, we are using the same formula again. So as I said earlier, all the limiting rules or formulas, they all came from limiting process, this very formula. So now, this is actually the reason why we saw this here, because this is the easy one to, again, to prove very quick. You don't have to go through many steps. If I have a constant value and I say f at s equal to 10, what will happen? F at s plus h will be 10. F at s will be 10. So 10 minus 10 is what? 0. And if h is approaching 0, that means h also is what? 0. So that's why the limit of a constant value is always 0. And this is what is here. C can be any constant value and is 0. This is the quickest, one of the quickest rule that we can prove with only 2 or 3 steps. The rest of the power rule, addition, subtraction, it's easy to prove it. Our course didn't prove, our textbook didn't prove it, but there are some calculus like in engineering schools or computer science, some is required to prove it. And even they do like trigonometry functions for. Here we are not going to do no trigonometry functions for calculus again. This is business calculus. So that's the symbol here. Constant is always 0. Now, if I have a constant value and I have an equation, leave the constant value alone. Don't touch it. Then apply any, if this is a power rule, use the power rule. When you finish, multiply by the equation. So that's why here they say derivative of y equal to c times u at x. Find the derivative of u at x. That's it. The answer you get, multiply it by the constant value. And that's the coefficient constant. You can see if I have a f at s equal to c times u at x, c, don't touch it, leave it. Find the derivative of u at x. So that's the answer here. This can be any function. It can be a power, addition, subtraction, multiplication. It can be anything, but whatever it is, when you find the derivative of that function, you multiply it by c. So up to now, we went through 3 rules now. We know how to find the derivative of using the power rule. Derivative of a constant value is always 0. Even that one, they didn't give us any example in the test because it's straightforward. Derivative of 10, if the function is 10, is 0. If it's 100, is 0. Anything is 0. Any constant value is 0. Then we find the derivative of an equation with a constant value, and then the function itself. And we have to find the derivative of the function. The answer we get, we multiply by the constant value. So we say the coefficient. So that's what we have here. You see that here we are going to apply the power rule again in A. Actually in B also the same, C also the same. We are going to apply power rule. But also we have a constant value in front. And the rule here said we shouldn't touch the constant value. Just multiply it. I have to find the derivative of s to the power 5. And that will give me 5x and 4 to the power 4, because the exponent 5 will come to the front of the x, and I'll subtract 1 from the 5. That's the power rule. So, and this is 4, so I'll multiply it by the 4. So finally, the answer will be 20x to the power 4. And that's what we have here. The 4, we didn't touch it. Find the derivative of s to the power 5. Now we are using the power rule. So we get 5s to the power 4. So we multiply now, we get 20s to the power 4.
And that's the coefficient rule?
Yeah. So the reason why they mention coefficient rule, because you remember 4 is our coefficient value. But s to the power 5 is our power rule. So here we are using 2 rules here. We are using the power rule to find s to the power 5, which is 5s to the power 4. The coefficient rule means just multiply 4, because when we look at the rule here, they just tell us multiply, that's it. The coefficient is c. Multiply c by the derivative of the function. The coefficient rule again, always multiply the coefficient. Coefficient will be a value, constant value. So if no question, it's almost time now. Let's see if we can finish this B and C before we go. So if you guys can give me 2 minutes or 3 minutes, we almost finish. Let's see the second example. I'll keep the half. Half is coefficient, so I don't touch it. What's the derivative of t squared? Power rule, it will give me 2t. The 2 will come to the front of the t.
Isn't it? That should be t.
Yeah, so that will give us 2t. We get 2 minus 1 will give me 1. So the exponent will be 1. Normally, when the exponent is 1, we don't write the 1. But since there's 2 at the top here, 2 will come to the front. So we get 2t. Then we multiply 2 by half. So what the student said is right. The answer will be half times 2 is 1. So the answer will be t.
Nice.
Then let's go through the next one, and that's it for today. So the next one, our coefficient is 5. So we keep the 5. We don't touch the 5. But remember previously, when we have, anytime you have a denominator, the variable is the denominator, try to bring it up. Then change the exponent to negative. So we know square root is half. We bring it up, it will be negative half. So this is our function now. So now I'll keep the 5, and I'll use the power rule for q to the power negative half. So negative half will come to the front of the q, And then minus half minus 1 will give me minus 3, 2. Combine this, multiply 5 by negative 5 will give me negative 5 over 2. Then I want to take the negative 3, 2 down so that I change it to positive. So it will be square root of q cube. Again, you don't have to use the square root symbol as we said earlier. You can just write the answer equal to q 3 by 2 or square root of q 3 or 3 cube. So I'll wait for a few seconds. Again, we pass almost 3 minutes past our time. I'll wait for a few seconds if any question.
Yeah, Professor, could you go back to the slide with the coefficient rule? Yeah,
Right here.
Yes, thank you.
Again, I'm recording it. I'm going to post this recording in week 2. The Tuesday, you'll see the last video on Tuesday is in week 2 for that. The last video, that's our classroom. So always the last video will be our classroom lectures. And again, I have these lectures also in my previous videos, classes, the previous classes that I teach. I posted them in my YouTube channel also. So either way, you should be okay. If no question, I will keep going. I wish we still have time, but we don't have no time. So what I'm going to do, I'm going to look at the assignment. I thought I'll finish derivative of sum and differences. So let me see the questions if we have any question that covers derivative of the sum and difference. If there's a question, then I will tell you not to solve them. Again, if you can solve them, that's fine. If you cannot solve them, just leave those questions but I'll go through right now. So yeah, the first question should be okay. Simplify the following. Second question, you are using the limiting process. Again, you are finding the derivative of minus 13x minus 14. You are finding the derivative, but they say what? Using the given function definition, and they gave you the function here. So which means anywhere I see here 13 minus 13x minus 14, you have to use the function here to find this. Remember, this is f. The original function again will be f at x plus h minus f at x. So we covered this already. Given f at x and g f at, okay, this one. So this is algebra composition function. We can see that we have f at s, we have g at s. How do you find f at g at x? Then later you substitute s with 3. This is pre-calculus, so just for the review of pre-calculus. Then actually the second question is, this is almost like the sum of derivative, but this is not a derivative. Here we are using limits. So we covered this even in the first lectures, how to find the limit of addition to functions. The rules are there in the first lectures. This also is okay. So we don't have any derivative of a sum. Okay. So you can see the question number 9. It's up to you if you can do it using the limit process. Actually, we covered this, so we use the limit process. Now here you have f at x minus 2x squared minus 9x. If I'm using the derivative formula, then I can use the formula to find each individual. I'll use the coefficient rule here. Then I'll use the regular rule. But again, here we are using limiting process. So here you have to use the f at s plus h minus f at s over h. You have to show your work. Do not use any formula. So all the questions here, there's no formula. So don't use any formula for the homework. So here we're going to use only the limiting process. If you want to find the derivative of any function here, then you have to use the limit h approaches 0 f at x plus h minus f at x over divided by h. So we should be able to solve all the 10 questions. Again, if you have any question, feel free to send an email. I will explain that again. The assignment is due. Let me stop this recording now.